No, that was pretty dramatic. Okay. Paid some money to get that, so with any luck, it had the desired effect. A lot of people have been complaining in the Unity forums that the input system makes clicking and dragging somewhat difficult. So I thought we'd talk about that today. Last time we talked about the input system a little bit. You can go to my YouTube channel, Professor underscore Stevens, and you'll see it. But today we're going to get into how you would actually simplify click and drag a little bit. And if we have the opportunity, we'll get to where we can have different objects exhibit different drag behaviors that are coded into the objects, not just into a centralized dispatcher. I think one of the problems with the input system so far has been that the tutorials that Unity offers tend to reflect a kind of single approach. They're looking for something that is driven by a player character, either third person or first person. I'm thinking more in terms of first person myself, but I want the player input to be directed ultimately to various objects in the scene. So without further ado, let's look at this simple scene that I've created, and it's nothing more than what it appears to be, a few geometric shapes, and I've added an input system to part of it, and also a fairly complex rig we're not going to get into today that lets me maneuver the camera around. So first off, let me just show you how this would run as a simple demo. We start off with the camera at this fixed distance, obviously. And then any place that I double click, if it's willing to accept me moving in, I can then be zoomed into that object as a kind of local center for me to orbit around. So if I double click out here in the open sky area, or down here in the ground as it were, nothing much happens. If I double click on the red square in front of me, I get zoomed in. If I right click, I zoom back out. There are several games that use this type of an interface, and we'll get into how that works down the road. Notice, however, that if I click and drag anywhere in the scene, I'm dragging now with the left mouse button down. I'm holding it down. If I click and drag, I rotate my point of view as though it were on the surface of an invisible sphere, and the center of that sphere is inside that blue cube that you see in front of you. Now, I said before, I've got it set up so that if I double click on something, it'll let me sort of zoom in. The camera actually doesn't do a traditional zoom. What it does is it actually moves, and that uses this hierarchical rig that I've created that we'll talk about some other time. Let's say I want to click on the red cube. It's willing to let me move in, so I'll do a double click on it now. By the way, in an actual game, a lot of this would have a somewhat different way of treating the cursor than I'm using now. I want to leave it visible so that it's easy to see what's going on as we interact with this demo. Now if I click and drag, look what happens. It's similar to what happened before. The camera appears to be on the surface of an invisible sphere. The sphere is rotating around depending upon which way I push the mouse while I hold the left mouse button down. But the center of the sphere has moved into the center of this red cube, not the blue one. Now, no matter where I am in terms of orientation, if I press the right mouse button, I'll back away and I'll change my point of view's direction to the center of the new sphere that I'm sitting on. That becomes a little more apparent if I use a different object. I'm going to double click now on the yellow sphere. Okay, now I moved in and I'm looking straight at that. Once again, I can click and drag. This time it's much more obvious that the center of my rotation, my orbit as I call it, is inside a different position. It's inside the center. It's actually at the center of this yellow sphere. Now if I do a right click and zoom back out, the effect is somewhat more dynamic. That doesn't have much to do with click and drag yet, other than this rotation. With existing input, the input class and the legacy style of Unity coding, that's not that hard to do, because all you need to do is add a collider, and then when that collider detects that the mouse is dragging, the on-mouse drag method gets called. They call it a message in Unity parlance. I don't know if that's all that helpful. But what I'm doing here is not using a collider. I don't need one for any of this. Instead, I'm using the input system. And I do have one case where a couple of cases actually in this demo where I can do something a little more interesting than just change my point of view. For example, this green box on top, if I click, I'm pressing the mouse button now, hold it down, and move the mouse, look what happens. It rotates. So that could be a control on a puzzle box. Similarly, this gray cube off to your right, if I click and drag that, watch what happens. Now, I don't know if you can hear the sound effect. There's a click that happens every so often as this thing rotates. So what I get in response to the mouse being pressed and then dragged depends on where in this game scene the cursor is when the mouse is pressed. This is something some people have complained does not seem to be easy to do in the Unity input system. So what I want to do is maybe go into some of how you could do that. It's not that hard. Like everything else, it's easy once you know how to do it. And it's a bit of a drag to set up. It's got a little bit of complexity to it. We'll try to keep it one step at a time. All of this is being driven by a class I created called point click. So let's have a look at the point click code. Now, yeah, there's a lot of it. It gets built up a little at a time. We won't need to get into all of this today. The important parts are here in the start method. Now, point click is just a mono behavior. It's the traditional style of Unity coding you've probably done a lot of. If you're looking at this line at all closely, you're noticing also that it's not just a subclass of mono behavior, but it also implements an interface I defined called IMouse. That's not in the Unity library. I created that. We're going to need to get into that in a few minutes. What I do in my start method is pretty straightforward. I'm only going to cover the things that are really relevant to dragging up front. We may come back, so don't let the fact that I skip a few lines here worry you. It's not going to be that big a deal. The first one that really matters is here at my line 29. I'm going to query my player input for its action map. Now, let me back up a couple of lines. The camera rig is a class I created that has a player input component on it. Player input component is something you add in the inspector. That's part of the new input system. So first I get my camera rig with the classic get component call. Then I retrieve its player input component, again using get component. Nothing terribly mysterious about that. Now things get a little bit more original. The player input object has a member called current action map. It's of type input action map, and that's something that you can create in the input action editor in the new input system. I did that last time we spoke. We can get into that some more this time too, especially if anybody wants to detail that, get some more detail on that. Now, what do I do with the map? Well, I need the actions that I defined for that map. These were the ones that I got to pick the names of. I've got one I call click, and that is bound to the left mouse press. And I've got another one called back, that's bound to the right mouse press. And I've got another one called drag, that's what you think, it's bound to the mouse movement. And I also have the escape key. We're not going to do much with that, but I did bind the escape key to an action named escape. So once I've retrieved an action, which I retrieve by name, then what I can do is add event handlers. I can subscribe event handlers to the specific phases of that event. Now, this is one of the things that people have complained about with respect to using Unity events in the new input system. In the editor, you're allowed to select objects from components in your scene, and then from those objects, you can pick a method that gets called when an event occurs. And the events here are actually, again, the actions in your input action. The trouble is that when you call one of the action handlers that way via the Unity event system, your method gets called for every one of the phases that action can be in. And so the very first thing you have to do is query that. You have to find out, usually through the argument that gets passed to that method, what phase is my action in. But you don't need to do that if you use the technique I'm showing you here. What I'm going to do instead of using the Unity event system is I'm going to use the C# event system. This is actually what the Unity event system is doing internally. So you're not really gaining or losing any overhead. You're just being a little more fine-grained about how you apply it. So I've got my input action here, and it's of type input action. That's part of the Unity class library that you get when you add the input system. But click has an event called started, and I can use the plus equals, the add-on operator, to tell the click dot started event that whenever it occurs, I want it to call this method on click started. I wrote on click started, so we'll get into that. Whenever the click canceled phase occurs, I want the click dot canceled event to call my on click canceled method. Notice I'm keeping consistent use of the traditional on method name. You want to keep your eyes open on that, because if you've decided to play life a little dangerously and you've told Unity you want to use both the new input system and the old input class, there's a danger that you'll inadvertently use a name that's already expected by the input class. You can get some really weird error messages when you do that. So keep an eye on your method names, even if you like using this consistent on something happens naming convention, which they were already using with the input class and the existing mono behavior messages, they call them. You may end up running into collisions of names, so just keep an eye on it. So basically all this means is that whenever a click event started phase occurs, my on click started will be called, and when its canceled phase occurs, my on click canceled will be called. This is almost identical to on mouse down and on mouse up, since I've mapped the mouse press to the click action. Little bit more interesting down the road is going to be how we handle drag. That's why we're here today. But I just want to be complete, so I'm going to mention we also get the back input action. That's the one that I bound to the right mouse button. And I only really care about its started event. When the right mouse button goes down, I want to get a started event, and I want that to be handled by my on back started method. And then finally, I'm going to ask for the drag input action. Now notice, unlike the others, I have not made this a local variable, the start method. That's because I'm going to use this dynamically, and that's what's going to make click and drag work so well for us in a few minutes. Just to round it out, I've also retrieved the escape input action, and I've mapped the escape started event. That'll tell me when the escape key goes down to a method that handles that. And that's just a way to get in and out of the game. Not something we terribly need to worry about. So where is drag defined? It's declared up here. It's member variable of the point click class, so we can use it again when we need it. Similarly, I'm also saving a mouse object, which I'm getting here, mouse.current. If you're worried about the sort of gaming where you might connect and disconnect devices while the game is being played, this static approach wouldn't work, but for our simple demo, this is going to be fine. So all this does is wire up some event handlers for us to the very specific events that handle the phases. This gets you out of all this nonsense where using the Unity events, you end up having to spend a lot of time querying for the phase to see is it started, is it canceled, and one we care about also that we'll see, performed. And we'll get to that in a moment. So let's look at my on-click started event handler. Now, these event handlers get called with an argument. It's a context argument, and you can use it to find out all sorts of interesting things. We won't be using it terribly much right now, but that is the argument that's passed. I'm going to want every time the mouse goes down to find out, is this a single click or double click? Now this is interesting. A double click actually sends 4 events. The initial mouse down will occur with a mouse click count of 1. Then you're going to get the mouse up event. That's going to call our on click canceled method. The second mouse down will again call on click started, but this time the click count will be 2. Unity manages that internally. Depending upon the platform you're on, it's probably relying on that operating system. Windows handles this, for example. Two clicks that occur within a certain amount of time and within a certain number of pixels of each other generate a double click event, but you never get out of the first one. So I think some people have told me they believe the double click is handled in Windows by waiting a little while after an initial click. And if a second click occurs, you only get a double click event message from Windows. That isn't what happens. You actually always get the initial mouse down message from Windows after the first of the two clicks in a double click. So you need to be able to handle the fact that all double clicks are preceded by single clicks nearby. That's not going to be a problem for us. But what does work beautifully as a result of this is that when a double click occurs, we can ask the click count value, are you 1 or are you 2? By the way, I've experimented with this, and you can go beyond 2. You can get any number you want because every subsequent click after its predecessor only has to occur within the time window that begins as of the most recent click. So you could do 50 clicks in a row and that click count would read 50 if no two of those clicks were spaced farther apart than whatever the time window is that your platform uses. On Windows, I believe the default is about a half a second, so it's fairly long. Now, what are we going to do? Well, on the single click, we are going to look at got a funny note in the chat box here. Sorry about that. What we're going to do is we're going to begin by assuming that this could be the beginning of a drag operation. And we're going to start by saying that the drag code, the object that's going to do the dragging, is ourselves. We may be wrong about that, but that's our fallback. That's who we're going to guess it is if nobody else wants to drag. How do we find out if in fact the click occurred on something else that wants to do dragging? Well, we're going to use the physics raycast method, and we're going to convert the mouse's current position, whatever that is. By the way, I could have used the mouse I saved here, but I said mouse.current again. It's not going to make much difference. We find out where that is, and we pass that as an argument to camera main screen point to ray. That's simply going to give us a ray for free, so we don't have to do any vector calculation. And then we're going to raycast that. We're going to shoot a ray out into the scene, and if that ray hits any game objects that have colliders, then we will get that game object returned in this output variable of type raycast hit. Notice that if we hit nothing, we will cheaply detect that because physics.raycast returns a Boolean false if nothing gets hit by the ray, so we can skip any further operation. Now, what would we do if that happened? Well, if you detect a raycast, your code is going to look at the object you hit and find out it doesn't want to do the dragging. Let's skip that for a sec. Let's assume we didn't hit one. This comes back false, and then what we do is we say current dragger, which is us, runs its on mouse down method. Notice that's not the same as on mouse started. That's the method that handles the event. That's on mouse, not on mouse started, on click started. That handles the click.started phase event. Here what I'm doing is I'm using a method that was defined in my IMouse interface, and I'm calling it based on my own assumption that this object we're looking at right now, is the dragger. And I'll pass the context so that it can have that if it wants it. Here's where we actually make the dragging happen. We're going to add our on-mouse drag event, our on-mouse drag event handler, our method, to the drag.performed event. Remember, we retrieved the drag input action back up here in start at line 40. We didn't do anything with it, but we saved it. And the reason we saved it is here in the onClickStarted method, when a single click occurs, when a single mouse down occurs, if we don't click on any other object, we are the current dragger. We go ahead and call our mouse down method so it can do whatever it does when a mouse click goes down. But we add our mouse drag method to the drag.performed event. Okay? Now, let's assume we don't do any dragging. What's the next thing that's going to happen? The next thing that's going to happen is that the mouse is going to go up. Well, that's going to generate a click.canceled event. And we have already registered our onClickCanceled method with the click.canceled event. Let's have a look at what that does. OnClickCanceled. Doesn't do very much. This one's short and sweet. It has the context argument like before. All we're going to do is we are going to remove from the drag.performed event list of event handlers the event handler that we added before. Whatever was in current dragger, that was us if we didn't hit anything, we remove the onMouse drag method. And we're going to call the onMouse up method of whoever the current dragger is. And again, if we didn't hit anything, that's us. Now, let's have a quick peek into IMouse. Those are the three methods in the IMouse interface: onMouse down, onMouse drag, onMouse up, and each of them expects to get an input action.callback context argument. And each of our methods that handles one of the events from the input system gets passed a context parameter as its own argument, so we're just passing that along. We don't have to generate one ourselves. Oops. Didn't mean to blow that up, sorry. Now, let's look at the more interesting case. If the physics.raycast returns true, that means we hit something. We've got a reference to it in the raycast hit collider game object member. Hit is of type raycast hit. The first thing you typically want to know is the collider that actually produced the hit. But in our case, we want to know about its game object because we subsequently want to know, does that game object implement the IMouse interface? So there's a little bit of serial dereferencing going on here. Stylistically, you might want to break this up into single dereferences because if any of them ever come back null, you'll want to know which line that was, which member was null. But reading from left to right, we take the hit returned from physics raycast, we dereference it to get its collider. We dereference the collider to get its game object. We dereference the game object so we can run get component on it. And we ask, do you have an IMouse component? Anything that implements IMouse and is also a mono behavior would be returned by this long serial dereference. And it would end up here. If it doesn't have an IMouse component, dragger will end up null. So we ask an obvious question. If dragger is not null, then we know that there is an IMouse component on that object that we hit, and that becomes the current dragger, replacing ourselves. The rest of the code's the same. After that, we call the current dragger's onMouseDown method. Remember, onMouseDown is a method that has to be defined by anything that implements the IMouse interface. And then we go ahead and add the current dragger's mouse drag event handler to the drag performed event. If we hit something, current dragger is that something, and it has to implement IMouse. We wouldn't have gotten a different dragger than ourselves if it didn't have an IMouse object. So we're adding that object's mouse drag. That allows the object to drag itself. It reacts to mouse movement after that without this class having to know how to drag the object. The other object will tell us how. It'll drag itself when we call this mouse drag onMouse drag method. In fact, we don't call it. The input system does. All we had to do is register it with the drag.performed event. And that's what makes the magic happen. Let's look at what happens at this top level. If we don't hit anything, to recap, we start by assigning ourselves to current dragger. If we don't hit anything, this if comes back false, which means the next line is this. Current dragger onMouse down, that's us, we're the current dragger, gets called, and it does whatever onMouse down does. And then we add the current dragger's onMouse drag method to the drag performed event. Current dragger is us in this example, so let's look at the onMouse drag method. By the way, notice our onMouse down is an implementation for the sake of fulfilling the obligation we have by saying we're going to implement the IMouse interface, but it doesn't do anything. At the top level, we don't want anything to happen in this particular demo. It's the objects we might otherwise click that could generate a result. But for us, single clicks do nothing on our default dragger. But the onMouse drag method does do a little bit. It gets the value out of the context, and that context knows values based on what type of binding was assigned to the action. In this particular case, the mouse drag is assigned to mouse movement, which produces vector2 values. So I can ask to read a vector2 value from this context, and that'll tell me how much the mouse moved. I'm going to put that into my own vector2 so that I can subsequently add the individual x and y elements to some angles that I'm keeping running totals in. And then I pass that to my camera rig. What does camera rig do with the angles? It reorients the position of the point of view. It changes which way it's looking. How it does that isn't terribly important to us right now. What's important is this method reacted to the mouse movement. And so the on-mouse drag method is being called now as long as it stays registered with the drag.performed event. That only happened because we clicked down on the mouse. Now, right after I click down on the mouse, after that, any subsequent mouse movement is going to cause the input system to call on mouse drag, this on mouse drag. That means that I can continue to pass changes to these angle values to my camera rig object. How it handles the movement's not important. What's important is I can do that by connecting the on mouse drag event handler to the drag.performed event. It stays connected, and so it continues to be called until onClick canceled is called. Now remember, current dragger continues to hold a reference to whoever provided the on-mouse drag method that's currently registered with the drag.performed event. That means that when the onClick canceled method gets called, which occurs when I let up on the mouse because the input system will generate a clicked.canceled event, which will call this. Remember, I registered this in my start method, so I don't have to re-register or deregister it. But what it does do is it deregisters the current on-mouse drag method that is receiving drag.performed events. And then it also calls the current dragger's on-mouse up method. Now, if that's me, we can find that down here at line 130. And again, I don't have anything that I need to do. I simply have to implement the method to fulfill the obligations of being an IMouse interface object. So that answers the question of how can we do click and drag without constantly having to receive drag events when the mouse is up. We're going to register a drag event handler when the mouse goes down. We're going to deregister it when the mouse goes up. Double clicks. How do we handle that? Well, let's look at the onClick started method. In the onClick started method, you've got the same switch, but this time if we get a second click, remember, to get to a second click we will have had a down click, which registers the drag method, the drag event handler, an up click, a click canceled, which deregisters it, which means as of the down click for the double click, there is no mouse drag event handler currently registered. We will switch off of the mouse click count. This time it's going to be 2. Well, we'll do the same thing. We're going to do a raycast, find out did we hit anything. This time we're going to ask, does that thing, if we hit it, does it have a double click interface? Well, what's in the double click interface? Quick look at that. Only one method on double click. So if our raycast successfully intersects another object and that other object implements the iDoubleClick interface, the only thing we're going to do is call the single method in that interface on DoubleClick. Notice I used what's called the Elvis operator here to skip the question about is DoubleClick null. This is a slightly more compact way to condition the execution of a method on whether or not the object you're dereferencing is actually null or not. I couldn't use that up here when I was checking to see if dragger was null because I didn't just want to call a method. I wanted to assign a value that would be persistent. So here what I'm doing is I'm simply saying to the object I double clicked, do what you want me to do. I'm telling you, object I double clicked, to run your on double click method. My point click class does not implement I double click, so there is no way to double click on it. Instead, what will happen if you double click in the open space around my game objects is this physics raycast will come back false because it won't hit anything. So what happens now is the on double click occurs, and on the next on click canceled, we will again remove the current dragger's on mouse drag method, but there won't be one registered. This will be harmless. You can always remove a method that isn't registered with an event, and it does nothing. It's effectively a no-op. So on the first mouse down, this will register an event handler. On the mouse up, it'll deregister the same event handler. On the double-click mouse down, it won't register it again. It will call any double-click objects that it finds with the raycast. It'll call their on double-click method, and when the mouse goes up again, this will get called, but nothing will happen, because the current dragger will simply be this at that point. So it'll be deregistering our own on mouse drag method, which isn't registered. So again, deregistering a method not currently registered with a C# event is a no operation. So how does this all work? Well, it drags us around. It changes the point of view of the camera when we run our own on mouse drag. But who else has an on mouse drag? Well, let's go back into the game. And notice that when I clicked on the green object, it also moved when I clicked and dragged. Well, how did it do that? Well, it's got a couple of scripts on it. There's a fly to me script. That's the one that handles double clicks. But there's also spin me. Let's have a look at spin me. Spin me does implement IMouse. Hey, now that's going to do what we want. What that means is that when I do a single click on the game object with a spin me method, that raycast is going to hit this object's collider, which means the object has to have one. That object's collider will generate a hit. We will use the hit to query the object to find out, does it have an IMouse object, an object that implements the IMouse interface. It's going to find out the answer is yes, and it's going to run that, it's going to register that object's on mouse drag method with the drag.performed event. From then on, until that method is deregistered, this gets called. Notice that my point click class will not have to do the calling. The input system will call this directly because this method is now registered as the drag.performed event handler. Every time the mouse moves again while the mouse is down, that will result in a call to on mouse drag. What does it do? Well, in this particular case, all I've got it doing is reading that vector2 value, it's always there, and using that, the x value of the mouse movement, to slightly rotate the object that the spin me script is on. That's why when I run this game, usually Unity speedy startup, that's why when I run this game, if I change my point of view, I can do that by clicking and dragging anywhere there's no collider. But if I click on this green object, which does have a collider, and hold the mouse down, okay, I just click the mouse and now I'm holding it. When I push the mouse down, the click started event called my on click started method. That in turn registered the on mouse drag method of the object I clicked on. Remember, why did it do that? Because the very first thing it does every single time the mouse goes down is it uses a physics raycast to find out, did the mouse get clicked down on an object with a collider? And if so, does that object have an IMouse object? Does it implement IMouse? The green cube does with the spin me script. As I continue to hold the mouse down and move it, the cube will move because when my code found the IMouse object, it registered that object's on mouse drag method with the drag.performed event. So now when I move the mouse, instead of calling point clicks drag method, it's calling this green cube's drag method. If I let up, and I click somewhere else, when I click down now and hold, I'm clicking and holding the mouse button, that raycast shot off into forever. Didn't hit anything, so the point click code says, okay, the point click object, I must provide the on mouse drag method, and that's what does this, rotates the point of view. Similarly, the gray cube has a script called revme. Revme also implements IMouse. So when I click and hold on the gray cube, what happens? Physics.raycast shoots a ray, It discovers that it hit the gray cube's collider. The gray cube has one. The gray cube then is asked, do you implement IMouse? Yes, it does. Therefore, the drag.performed event has the gray cube's mouse on mouse drag method registered to it, which again means if I move the mouse, every time the mouse moves, the input system is calling the event handler that was registered recently when I clicked the mouse down with drag.performed. This one rotates the gray cube around its x-axis. It also has a couple of other tricky bits where if I move and let go while I'm moving, it adds a little momentum to it. The green cube doesn't do that. That's a trick we'll visit in more detail down the road. So let's look at RevMe. If we look at the gray cube, which I call a side roller, you can see it's got a RevMe script. Let's look at the RevMe code. RevMe does implement IMouse, and here is that implementation. Not very long. What it does is on mouse down, it sets the gray cube's rigid body is kinematic to true, because as long as the mouse is dragging it, I don't want physics to control the rotation of that gray cube. I want the mouse drag to do it. It also knows that it has to implement on mouse drag. Well, my point click code will have detected that the gray cube has an IMouse. So what it does at that point is it registers this method, on mouse drag, with the drag.performed event. That's what results in this method being called every time the mouse moves. And here what I do is I figure out what the force is and I apply that, or I save the force of the mouse movement in latest force, because I'm going to actually apply the change of rotation in the fixed update method. The important thing is that this method will be called every time the mouse moves. And that's again done by the input system, not by my code. All my code had to do was register this method in this object with the drag.performed event. Eventually, the mouse key, I'll let the mouse button up. Point click will detect that because it will get its on click canceled method called, which will in turn figure out who the current dragger is, in this case the gray cube, and it'll call the current dragger's on mouse up method. At which point all I'm going to do is turn is kinematic back to false. That's part of what lets the cube continue to rotate a little bit. So this is how we do mouse down and drag with the new input system. By registering a drag handler when the mouse goes down, deregistering it when the mouse goes up. That gets you out of having to do any polling in a mouse drag event handler that would otherwise be called constantly, whether the mouse key was up or down, the mouse button was up or down. This is the complaint I keep reading about with the new input system and dragging, is that when you bind a mouse drag to an action, and then in turn you provide an event handler for that action gets results in the event handler getting called over and over again whether the mouse button is pressed or not. The solution is to register specifically with the drag.performed event, so you do not have to query the context to find out what phase is the event in, what phase is the action that generated the event in. You know what phase you're in because you register the event handler by phase to particular actions. And by registering only when the mouse started event, the click started event has occurred, and deregistering every time click canceled occurs, the mouse drag method only gets called when the mouse key is held down. That may seem complicated, it's hard to put into words, but the sequence makes fairly clean sense. When the mouse press goes down, your event handler registers a drag handler. When the mouse key goes up, that event handler deregisters the drag handler. So there is only a drag handler registered when the mouse key is down. Therefore, when the drag handler is called, it doesn't have to ask, is the mouse key up or the mouse key down? The drag handler can be written on the presumption that it is only ever called when the mouse key is down. And that results in exactly the behavior we've been wanting. So I'm moving the mouse all over my screen, and if I had registered a mouse drag method, it would be getting called now. But right now there is no mouse drag method registered with the drag.performed event. I click down on the mouse key. That causes the onMouse drag method of my point click class to be registered to the drag.performed event, which means as long as I hold that key down, mouse movement calls the mouse dragged method. When I let up on the key, the mouse dragged method is deregistered from the drag.performed event, and subsequent mouse movement does not cause it to be called. Same thing with the green cube. If I click on the green cube, my point click method does a raycast, detects the collision, queries the cube to find out if it has an object that implements IMouse, finds out that it does, and therefore registers that object's mouse drag method with the drag.performed event. That means as long as I hold the mouse down, subsequent mouse movement repeatedly calls that object's onMouse drag method. As soon as I let up on the mouse, it deregisters that method, which means, again, subsequent movement of the mouse does not result in calling the method. So your drag methods only ever get called while the mouse is held down. I've got three of them. One handles what I call the side roller, one handles the green cube, and one handles changing my point of view. So three different drag handlers result in three different behaviors. No one of them ever has to query anything to ask, what object am I dragging? No one of them ever has to ask, is the mouse up or down? Because the mouse up and down transitions register and deregister the event handlers. Once you've got that register-deregister operation nicely working, you don't have to worry anymore about querying or polling to find out what phase am I in, what position is the mouse button in. Simply registering and deregistering on the fly means that you will only have your mouse drag methods called when the mouse button is down, and by registering according to which object you have clicked on, which is why we use the physics raycast, the behavior you get in response to a mouse drag is customized to each individual object, and they're all decoupled from each other. No one of them has to be aware of the existence of any other. No one of them has to query which one am I dragging, nothing like that. And you do need colliders in the objects that will be implementing IMouse and that you will find with the physics raycast, but only because I'm using raycast to do it. That's all the collider provides me with, is a way to determine where I clicked. If you want to use a different method, you might not even need a collider at all. All you really need is a way to find out, have I clicked on an object that implements IMouse? If I have, I need to register that object's onMouse dragged method, and then when the mouse click is over, when the mouse click goes up, deregister the same one. That's why I maintain a record in current dragger in my point click class. I keep track of whichever object it was that provided the mouse drag method that I register, and that's why current dragger is not local to onClick started. It's a private member variable of the point click class, and it's of type IMouse. That's all it has to be, is a reference to whatever object it was that implemented the IMouse interface, and that's going to get its mouse down, mouse drag, and mouse up methods called when the appropriate events occurred. We will call mouse down and mouse up directly from here in point click. The input system will call the onMouse drag method for us for whatever the current dragger is, because we registered it here. And again, because we remembered who the current dragger was, we can deregister it on the click canceled event here. Okay, I think that covers it for the input system and how to use it to do click and drag. You do not have to poll. You do not have to do a lot of querying. You do not have to handle a lot of dragging that doesn't actually do anything for you. Just register and deregister your drag event handler at the appropriate times when the mouse goes down and up. You got to keep a little bit of an eye on the mouse click count, so you know, am I handling the first click of a single or possibly double click event. Remember that double clicks with the mouse will always generate a single click first. It doesn't hide that from you. But the second click, when it occurs under the conditions that define it to be a double click, you can test for that in your click started event handler simply by looking at the mouse click count, which you do with read value. You actually have to make a method call to get it. You can't just read the click count. You've got to dereference click count as a member and then do this to it, read a value out of it, which obviously means there are probably other things you can do at click count too. Then you simply switch off of it. And if you ever exceed 2, in this particular case, I just don't have it do anything. It just ignores all of those. So that'll be that, and I will put some sample code up that handles this in the Dropbox. There's a link for that in my page, and let me know if you want to see this developed any further, or if you have any questions, and I will see you next time.